Hi, my name is Noor. Today we talk about a sign material with my friend Ranim and Isra. In the beginning, we talk about sign as a biomaterial. Sign is a polysaccharide derived from chitin. Chitin is the second most abundant polysaccharide in the world after cellulose. The presence of amino group in the sign structure might be protonated, providing solubility in diluted acidic aqueous solution. Several remarkable properties of cytosine offered unique appearances to the development of biomedical application. The polycationic nature of the cytosine also allow explaining cytosine analgesic effect. Now, to explain cytosine biodegradability, it is important to remember that cytosine is not only a polymer pairing amino group, but also a polysaccharide which consequently contain breakable glycosidic bond. Cytosine is actually degraded in vivo by several proteases and mainly lysozyme. Now we talk about the properties of cytosine. Cytosine it has many properties such as it's biocompatible, biodegradable, and the most point important in the properties of cytosine is non-toxic of the body. Mild processing condition, synthetic polymer often need to be dissolved in harsh chemicals. Cytosine will dissolve in water passed on pH. Availability of chemical side groups for attachment to other molecules, and the last one, antifungal effects, wound healing, acceleration, and immune system stimulation. And in this point, we talk about chemical structure of cytosine. In the picture, we show the chemical structure of cytosine. Cytosine differ from chitin by the presence of amino groups, which appears in its solubility in dilute acids. pH is less than 6, and forming complexes with metals ions so that it can be used for wastewater treatment and purification. The aqueous solubility of cytosine is pH dependent, allowing processability under mild conditions. Cytosine molecules have both amino and hydroxyl group, so that it can form stable covalent bond via several reactions such as etherification, esterification, and reductive amination reaction.
Okay, my name is Isra Absi and I will continue about chemical structure of chitosan. Chitosan has positive charge that can bend to negative charge on red blood cell RBCs, so that the chitosan used as hemostatic agent. We have two mechanisms to explain antimicrobial activity of chitosan. The first mechanism is the positive charge in the cytosine could bind with negative charge at bacterial cell surface, which alter permeability and leaks solute outside the cell. And the second mechanism is it could, it could bind with bacterial DNA cell, which inhibit RNA synthesis. Okay. Due, due to chitosan ability to function in many forms, it has many areas of interest within the medical industry. Some example of biomedical application is artificial skin, surgical structure, artificial blood vessel, control drug release, contact lenses, bandage, and hemostatic agent. Chitosan has show biocompatibility in biomedical application, such as a suture, artificial skin, and that has approved from FDA. And the citizen's viscosity and solubility and the citizen's viscosity and solubility depend on the molecular weight and the degree of deactivation. The degree of deactivation is determined by nuclear magnetic resonance spectroscopy. And the main application that we will focus in is the Chitosan hemostatic bandage. The Chitostan hemostatic bandage are an effective means to stop several external bleeding. They can be used in conjunction with a tourniquet to control several bleeding. They shouldn't be used for minimal to moderate bleeding.
Okay, I am Ranim Hatamle. I will continue the presentation from this point. Then the bandage must be held in place for 2 or 4 minutes. It should only be used to control severe bleeding. When the tactical situation allow for the time to apply the bandage severely. The hemostatic bandage may be cut to better fit individual wound. Now we will talking about the step to use this bandage. Hold the foil over pouch so that the instruction can be read. Identify unsealed edges at the top of the over pouch. Next, we will open the over pouch by pulling the unsealed edges part. Do not allow the bandage to fall to the ground. Now we put the bandage between the bottom foil and non-absorbable tan or green polyester backing with your thumb and hand. Hold bandage by the non-absorbable polyester backing and describe the foil over pouch. Hand must be dry to prevent bandage from sticking to the hand. At last, we place the cream-colored sponge portion of the bandage directly into the wound area with the most severe bleeding. Apply pressure for 2 or 4 minutes or until the bandage adheres and the bleeding stops. Once applied and it contact with the blood and other fluid, the bandage cannot be repositioned.
When the bandage becomes wet with blood or body fluid, the chitosan material becomes extremely adherent, like superglue, and seals the hole in the blood vessel. That is why it must come in close contact with the bleeding vessel.
Okay, thank you for
Thank you
listening.
for listening.